Hi students, welcome to derived units. These are the units which is obtained from 7 basic units or fundamental units are called derived units. These type of derived units, they are obtained by multiplication and division. So some of the derived units which we are going to discuss is as follows. Coming to the first derived unit, it is a area. Area, it has a formula, length into breadth. The SI unit of length, we know it is a meter into meter. So SI unit for area is meter square. So area, it is an derived unit. Second, volume. Earlier we have discussed about volume. It is described as length into breadth into height. The SI unit of length, meter into meter into meter. So SI unit of volume is meter cube or cubic meter. Third derived unit is density. Density, it is mass by volume. Mass, SI unit is kilogram divided by volume, SI unit is meter cube. So that is SI unit of density is kg per cubic meter. The fourth derived unit is velocity. Velocity is distance by time. Distance is nothing but length. Length, it has the SI unit meter and time is seconds. So that is SI unit of velocity, it is meter per second. The fifth derived unit is acceleration, which is velocity by time. Velocity, SI unit is meter per second and time is second, that is meter per second square. Acceleration. The next derived unit is force. Force is mass into acceleration. Mass is kilogram into acceleration is meter per second square. So that is kg meter per second square. The next comes pressure. Pressure is described as force by area. Force is SI unit, it is kg meter per second square whole divided by area. Area SI unit is a meter square. So meter cancels. So that is a kg per meter per second square. Next, significant figures. Let me go with a very simple example. Let us say that there is a running competition. Runner A, he takes 20.1 seconds. Runner B, he takes 20.2 seconds. If I ask you a question, who will win the race? Definitely your answer will be runner A will win the race, because runner A, he has taken less time. So these digits 20.1, 20.2, they are important. They tell exactly who won the race. So significant figures, it gives a meaningful or importance to certain digits, are called as significant figures. Here we can find two types. These are obtained by counting the numbers. For an example, if you go to a shop and ask a dozen of eggs, dozen means it is exactly 12. And by measurements, suppose if I say volume of liquid is 6.0 ml, it is a 5.9 to 6.1 ml. So there are certain rules to identify these significant numbers or significant figures. So coming to the very first rule, which is very simple. All non-zero digits are significant. For an example, 1, 2, 3, 4, 5. These are non-zero digits, means other than 0. 5.47. Here decimal, it does not count. The number of significant figures here 1, 2, 3, 4, 5. It is a 5 significant figures. In the second case 1, 2, 3, there are 3 significant figures and decimal does not play any role. Second rule, zeros between two non-zero digits are always significant. For example, 2005 and 8.06. The total number of significant figures here 1, 2, 3, 4. 4 significant figures. There are 2 zeros between 2 and 5. In the second case, the total number of significant figures, it is 3. 0 between 2 non-zero digits, they are significant. Rule number 2. Third rule, it says 0 to the left of the first non-zero digit are not significant. For an example, 0.134, 0.013, 0.003. The number of significant figures here, 1, 2, 3. 3 significant figures. In the second case, 0.013, these are significant, it is a 2. Here it is a 3. And in the third case, only one significant figure. 0 to the left of the first non-zero digits are not significant. So we have to consider only these three, 2 and 1. Fourth rule, it says 0 at the end of non-zero digits with decimal are significant. For an example, 83.0, 2.70. Total number of significant figures, 1, 2, 3. It has 3 significant figures. And here 1, 2, 3, 4. It has 4 significant figures. And the last rule says 0 present without decimal are not significant. 270. So total number of significant figures here it is 2. Rounding of numbers. It means the digits which are not significant, they are removed. Rounding of numbers is done to retain only significant figures. So rounding of numbers, it is done by following 3 rules. Rule number 1, it says the digit to be dropped is greater than 5, then add 1 to the remaining last digit. For an example, let us take the number 62.138. The last digit 8 is greater than 5. Now we have to add 1 to the number 3. It becomes 62.14. Second rule, it says the digit to be dropped is less than 5. In such cases, it should remain as it is. Then it is not changed. For an example, 28.133. Now it is less than 5. So this has to be maintained as it is. The value is 28.13. The third rule says the digit to be removed is 5. Then add 1 if the digit is an odd number. Suppose if it is an even number, it is remain as it is. For an example, 6.75 and 6.45. The last digit is 5. Add 1 to the number 7, it becomes 6.8. And in the second case, 4 is an even number, so it has to be remained as it is, 6.4. So total number of significant figures here is 2, and this is also 2. So coming to the calculations involving significant figures. In case of addition and subtraction, the final result or the final answer, it has to be reported with the least decimal place, whether it is addition or subtraction. For an example, let us take 11.1, 2.11 and 0.111. The sum will be 13.321. Total number of decimal places, here it is 1, second case 2, and here it is 3. Number of significant figures in 11.1, it is 3. Second case, it is 3. Third case, it is 3. The minimum decimal place is 1. Minimum decimal place is 1. So the final answer, it has to be reported with 1 decimal place. So the final answer will be 13.3. This is in case of addition and subtraction. The same thing happens in case of multiplication and division. Least decimal places has to be given for final answer. Say it is 2.5 into 1.25. So the sum will be 3.125. Here the decimal place is 1 and here the decimal place is 2. So we have to select 2.5. So the final answer will be given as 3.1. Scientific notation, it is a way of writing very large numbers and very small numbers in a simple method is called scientific notation. Scientific notation, it is represented as n into 10 to the power of n, where small n, it is an integer and the capital N, it is the digit, exponent form and the numerical form. While finding out significant figures for scientific notation, exponent portion is not significant and the numerical portion is significant. For an example, 1.3 into 10 to the power of minus 3, 1.3 into 10 to the power of 3. Exponent form will not have any significance. So it is only the numerical part. Total number of significant figures will be 2. Now let us write a numerical value 478.7.2 in scientific notation. So shift the decimal to the left hand side, 1, 2, 3. So it is written as 1.4872 into 10 to the power of 3. Similarly, if we take 0.000023, it is written in scientific notation as moving the decimal to the right hand side. 1, 2, 3, 4, 5. That is 10 to the power of minus 5 into 2.3. When we move the decimal to the right hand side, negative. Moving the decimal to the left hand side, it is a positive. Writing in scientific notation. So scientific notation in case of addition and subtraction, the exponent form, it should be same. If the exponent form is not same, it has to be made same by changing the small numbers. So here 4.236 into 10 to the power of 4 plus, shift the decimal to the left hand side, 0.3582 into 10 to the power of 4. So that gives 4.236 plus 0.3582 into 10 to the power of 4. The final answer will be 4.5942 into 10 to the power of 4. In case of subtraction, 10 to the power of minus 2, 10 to the power of minus 3. Exponents are not same. So let us change it. 2.5 into 10 to the power of minus 2 minus 0.48 into 10 to the power of minus 2. Small number is minus 3. So that is 2.5 minus 0.48 into 10 to the power of minus 2. So that gives 2.02 into 10 to the power of minus 2. Subtraction. So coming to multiplication, bases are same, powers has to be added. It becomes 10 to the power of x plus y. In case of multiplication, so that is 2.4 into 5.6 into 10 to the power of 3 plus 5. So that becomes 2.4 into 5.6 into 10 to the power of 3 plus 5. That is 3.44 into 10 to the power of 8. Next, in case of division, 10 to the power of x by 10 to the power of y. Shift y to the numerator, then it becomes 10 to the power of x minus y. This is in case of division. That is 4.7 by 6.82 into 10 to the power of 12 minus 20. So 4.7 by 6.82, it is 0.695 into 10 to the power of minus 8. Moving the decimal, 6.95 into 10 to the power of minus 9. The number of significant figures in pi is, pi value it is 22 by 7. So it gives a value of 3.14. It goes on. So option is a B, infinite. Because it is having unending decimal places. So option B. In which of the following numbers all zeros are significant? It is option A. Because zeros at the end of a number with decimal are significant. Hence option A is correct. 5,000 with 3 significant figures is written as 5,000 with 3 significant figures. Here it is 2 significant figures. Here it is infinite. Here it is 3 significant figures, hence option C. And here it is having 2 significant figures. How many different scientific notation can be written for 10500 grams? So it is option B. 3 different scientific notation. Like we can write 1.05 into 10 to the power of 4, 1.050 into 10 to the power of 4, 1.0500 into 10 to the power of 4. So it is a 3 scientific notations. The number of significant figures in 560 kgs is option C. It can be 3 significant figures, it can be 2 significant figures. So that is a 5.6 into 10 to the power of 2, 5.60 into 10 to the power of 2. 2 significant figures, 3 significant figures. Hence option C.